In 1994, somewhere in the chaos of Commodore International's liquidation sale, a buyer walked away with a computer that officially did not exist. It looked like a Commodore 64's sleek cousin, stamped with a serial number, sealed inside a case that said Commodore 65. No manual explained it, no store had ever sold it, and no advertisement had ever mentioned its name. Today, collectors still track down these machines by serial number, some bearing numbers under 200, evidence of a computer that Commodore built, tested, refined, and then quietly buried. This is the story of how that machine came to be and how it ended up in the hands of people who were never supposed to see it. By the mid-1980s, Commodore was sitting on one of the most successful products in the history of computing. The Commodore 64, released in 1982, would go on to sell more than 20 million units before its production run ended in 1993. A figure that remains unmatched by any single computer model. But success bred complacency. In 1985, Commodore tried to build on that momentum with the Commodore 128, a machine that could run three separate systems, its own native mode, a CP/M mode via an onboard Z80 processor, and a Commodore 64 compatibility mode. Most owners simply used it as a slightly better 64. The native software library never caught up, and the 128 mode from it was rarely touched. Meanwhile, Commodore's own Amiga line was pulling attention towards 16-bit computing, and Nintendo's game consoles were carving away the low end of the home market. By September 1989, Compute's Gazette put the problem bluntly, writing that sales of the 64 had diminished rapidly, that Nintendo had eaten big holes in the market, and that the life of the old warhorse computer should somehow be extended. That same Gazette article gave readers something more than a warning. It reported rumors circulating through the industry of a new machine. One insiders were calling the 64 GS. The specification sounded almost too good for an 8-bit machine. A GE802 processor, a version of the 65816 chip, running at 4 MHz, with 128 kilobytes of RAM expandable to a full megabyte. Fully expanded, it was said to support 256 colors and a resolution of 640 by 400 pixels. It would include a built-in 3.5-inch disk drive, support the 1581 drive, and offer enhanced stereo sound. The price was rumored at $300 to $350 with a November debut. None of that happened on schedule, and the very next issue of the Gazette reported a fresh rumor that the machine would never see daylight at all. The article also let slip something revealing about the mood inside Commodore. Sales staff wanted the machine out the door as fast as possible, while the engineers building it had taken to calling it mockingly son of +/4, a jab referencing one of Commodore's earlier commercial disappointments. The rumors were not far from the truth. As early as 1987 and in earnest by 1989, a small team at Commodore was developing what they internally called the Commodore 64DX. Fred Bowen led the effort, taking responsibility for writing BASIC 10.00 and the system's kernel, a major upgrade from the notoriously bare-bones BASIC 2.0 that had shipped with the original 64. Bill Garday designed the new graphics chip, the VIC-3, officially the CSG 4567, but nicknamed Bill after its designer. Paul Lassa built the DiaMagic chip, a DMA controller and blitter meant to speed up graphics operations. Victor Andrade worked on the CSG 4510 processor, nicknamed Victor in turn, and would later go on to help design AMD's Athlon CPU. Terry Fisher rounded out the core team. Their goal was straightforward on paper and difficult in practice. Keep the machine backward compatible with the enormous existing library of Commodore 64 software, while pushing the hardware close to what Amiga owners already enjoyed, all at a price the home market could still afford. What the team built was, by 8-bit standards, remarkable. At its heart sat the CSG 4510, a 65CE02-based processor clocked at 3.54 MHz, more than 3 times the roughly 1 MHz of the Commodore 64's original 6510 chip. The VIC-3 graphics chip supported 6 video modes, scaling from 320 by 200 all the way up to 1280 by 400 pixels, drawing from a palette of 4,096 colors. Sound came from 28580 SID chips, giving the machine genuine stereo output instead of the single-chip mono of its predecessor. The base machine shipped with 128 kilobytes of RAM, but a trapdoor expansion port on the bottom, styled after the Amiga 500's memory slot, allowed for expansion up to a claimed 8 megabytes. A 3.5-inch floppy drive was built directly into the case, compatible with Commodore's existing 1581 drive, and an external drive called the 1565 was planned as a companion. Taken together, it was a machine designed to stand with one foot in the familiar 8-bit past and one foot in the emerging 16-bit future. By 1990, the project, now renamed the Commodore 65, had reached a working prototype stage on what engineers called a Revision 2B motherboard. Commodore built roughly 205 units on this board and distributed them to company offices around the world and to outside software developers for testing. These early machines were rough. The basic 10 interpreter was incomplete, and several of its commands pointed to code that had not yet been written, throwing errors when triggered. RF video output did not work. Of the two SID chips meant to deliver stereo sound, only one functioned. The boards ran hot enough to raise concerns. Engineers pushed forward anyway, refining the design into a Revision 5 board that ironed out many of these problems. But time had run out. The machine had been targeted for a Christmas 1990 launch, and when that season arrived, the C65 still was not ready. Commodore instead rushed out a stopgap, the Commodore 64 game system, a repackaged 64 dressed up as a game console. It was not well received. Of roughly 80,000 units manufactured, only about 25,000 ever sold. In 1991, with a working Revision 5 board finally in hand, the Commodore 65 project came to an end. The decision to kill it was made by Irving Gould, Commodore's chairman, though the exact reasoning behind the call is not spelled out clearly in surviving records. It is easy to imagine the business logic, a low-margin 8-bit machine competing for engineering attention and manufacturing resources against the Amiga line, arriving years later than originally planned, in a market that had already begun shifting decisively towards 16-bit and eventually 32-bit systems. The internal skepticism captured by that Compute's Gazette nickname, Son of Plus/4, may well have proven prophetic. But sources differ on the finer details, including exactly how many prototype units existed by the time the axe fell, and no single document lays out Gould's reasoning in his own words. What is certain is that a nearly finished computer with working silicon and a refined board revision was shelved rather than shipped. Commodore International collapsed into liquidation in 1994, and in the process of clearing out warehouses and offices, a number of Commodore 65 prototypes made their way into private hands. Nobody agrees on exactly how many. Estimates run from as few as 50 to 200 units, with some collectors pointing to the low serial numbers on their own machines, arguing for a figure well under 200, while other accounts suggest a number closer to 1,000, and broader estimates stretch as high as 2,000. What's certain is that they exist, cataloged today by serial number by collectors and preservationists who treat each unit as a small archaeological artifact. The machine's influence didn't end there. In recent years, a project called the Mega 65 has set out to finish what Commodore never did, using modern FPGA hardware to recreate the C65's chipset and complete its vision, running the same basic 10.0 and supporting the video and sound modes its original designers only got partway to shipping. The Commodore 65 never reached a store shelf, and it never got to prove itself against the Amigas and game consoles that were reshaping the market around it. But it survives anyway, in scattered prototypes and in a modern revival, a reminder that Commodore's engineers were still capable of building something ambitious even as the company itself was running out of time.